So hopefully, and you've seen some of the previous videos, and hopefully Mike got you sort of excited in his last one around how you would make use of this technology, why you would actually be interested in it. So let's talk a little bit about when you might actually give this a try, because if it's a new technology to you, you're not likely to want to just say, hey, let's take this really important project that our company is setting its sights on, and let's try out this new technology that may or may not work for us. So let's look at some of that. Well, first of all, a great opportunity to introduce semantics is when you're dealing with a lot of heterogeneous data. So we keep harping on the fact that this technology is built to federate, it's built to bring information in from multiple sources, and it's built to take information that looks different and be able to make it look the same. And heterogeneous data is a perfect example of that. If I've got a lot of different data in different places, it's set up in different ways, and I want to create a more unified view of that information, I want the relationships within it to be consistent, semantics and an ontology are a powerful way to accomplish that. And so if you have a project that's starting to think about, I want to bring a lot of data together, this would be a great chance to try it out, let programmers get a feel for what is it to create an ontology, and concepts called bridging ontologies to bridge between the back-end data stores and the formal ontology that's been created to represent the concepts, and start to get a feel for how to use the reasoner, etc. This is a nice way to do it. Another place, and we deal with a lot of this in agile projects, is when the data structure is not clearly understood at the beginning. So if we're going through a journey of building out some solution, and part of that journey is to figure out what is our data structure, what are we going to be storing, how much is it, what are the relationships within it. Semantics, again, because of that flexibility of the directed graph based on the triple, that flexibility allows us to kind of add new concepts fairly simplistically without breaking previous work. So the refactoring effort, if you think about agile methodologies and refactoring code, it's easier to refactor our graph and the design of our data in our graph, just like it's relatively easy to refactor some of our decisions maybe in our Java code, as compared to a relational database and refactoring that structure and then having to figure out how to recast the data within the new structure, etc. So there are tools and techniques to do that. So this is another opportunity where you can try it out, and introduce it during some sprints and not put an entire huge project at risk. If you're dealing with a lot of rules in the data, so we've talked about the fact that a fundamental piece of technology involved with semantics is the reasoner. And the reasoner is really a sort of inference engine. It's an inference engine that knows how to use standards like OWL and RDFS. But at the end of the day, it's doing inferencing. And that reasoner is great if you have data where there are rules about relationships in the data and you want to start making use of them. You want to infer those relationships. So as data arrives in the system, let's say that you've gone through an exercise, you've done some analytics, and you've built a model using analytic techniques, and you know that certain relationships should be used to infer other data that you would then use in a downstream reporting system or in a workflow system to make a decision. You can place those rules now in the ontology and have them actually processed as part of the data structure instead of worrying about pulling the data out and maybe into a separate rules engine. So it gives you another location close to the data now where that information can be reflected and built in real time. This is great if you think about web services and integrations. If those inferences are made at the data layer, I don't need to worry about, gee, if somebody makes a web service call into my data, will they get the same picture that somebody using my rule engine might get? Those kind of issues start to become less of a concern because now the data itself is the repository for some of those rules. Language flexibility, of course, the web makes language flexibility straightforward. There are a lot of standards around that in the way that we design our schemas, etc. And because the semantic technology is based on top of a lot of these standard protocols, we get the language flexibility essentially for free. Another beauty of using semantics to do integration is it starts to give us some vendor independence. So right now, if you think about trying to federate information between an Oracle data store, a MySQL data store, and an MS SQL Server data store, there might be some complexity with making that all work. Because the semantic technology doesn't really care anything about those specific technologies and it can give you a unified view, it starts to give you some independence from what are capabilities of Oracle versus what are capabilities of MySQL. I can house them within a central repository that has this semantic view on it. And then I can use that for reporting or analytics, etc. So there's a lot of power to just starting to think about how to separate yourself from those individual vendors. And then finally, again, as we keep talking about, this technology is built to work with other technology. It's not meant to replace existing systems. It's not meant to replace relational databases. They will continue to have their place. But it does augment what we can do with those systems. It makes them better. It makes them more effective. It allows us to be more agile with them. And that's a big part of this, is the fact that we can augment our current infrastructure and get a lot of value out of those systems by adding these concepts.